Dear students, in today's video, we are going to discuss the electric potential due to dipole. We will do three different expressions. In first expression, the point is lying on the axial line of the electric dipole. In the second expression, the point is present on the equatorial line of the electric dipole, and in the third expression, the point of observation can be anywhere around the dipole. Let us start with the definition of electric dipole first. The electric dipole is a pair of equal and opposite charges separated by a small distance. Minus q is the one charge, plus q is the another charge. They are separated by a distance 2a. O is the center of the dipole, so it is divided into two equal parts. The distance of minus q charge from the O is a, and the distance of plus q charge from the O is again a. These charges can be any, for example minus 7 coulomb or the plus 7 coulomb, and the distance is small. So minus 7 coulomb and the plus 7 coulomb separated by a small distance, I say it to be 1 micrometer. So this combination makes up an electric dipole. The first is derive an expression for the electric potential at a point along the axial line of a short dipole. So we have a dipole minus q charge plus q charge separated by a distance of 2a. We extend the dipole axis. The point P lies on the axis of the dipole such that this point P has a distance r from the center of the dipole. O is the center of the dipole and the distance is r. Then the electric potential at point P due to dipole will be V is equal to V1 plus V2. V1 is the electric potential due to charge minus Q. V2 is the electric potential due to charge plus Q. So it will be 1 by 4 pi epsilon naught minus Q by AP. This is the expression for the electric potential, that is 1 by 4 pi epsilon naught Q by R. R is the distance of the source charge from the observation point, right? So in that case, if you choose your minus Q charge, the distance is AP, right? And if you choose plus Q charge, the distance is BP, this much distance only. So AP is what? If you want to calculate the AP, this is R, this total distance, and this A. So it is R plus A, and BP is what? R subtracted by this much distance, so it is R minus A. From the expression, Q by 4 pi epsilon naught can be taken common. Inside you are left with this term. This can be solved because you know that A minus B and A plus B are written as A square minus B square. So the bottom is R square minus A square, and on the upper you have R plus A and minus R. Minus A was there, but this minus shift this minus sign into plus, right? R and R will get cancel out, so you have Q by 4 pi epsilon naught 2a by R square minus A square. The product of Q and 2a is equal to P. This is called dipole moment. So V is equal to 1 by 4 pi epsilon naught P divided by R square minus A square. We know that the distance of the dipole charges is small. So A is very small as compared to R. So we can neglect this A over here. So the potential due to dipole comes out to be 1 by 4 pi epsilon naught P divided by R square. Potential due to single charge is inversely proportional to R, but potential due to dipole is inversely proportional to R square, right? This thing is to be kept in mind. It can be asked as an objective question. If you calculate the potential due to a point charge, that is inversely proportional to R, but the potential due to dipole is inversely proportional to R square, inversely proportional to the square of the distance. The next, we start up with the next expression, that is to calculate the electric dipole on the equatorial line. What is equatorial line? Equatorial line is a line perpendicular to the dipole which makes an angle 90 degree over here, and it passes through the center of the dipole. Any point which lies on this line is called the point on the equatorial line. This can be any point, right? We choose a point P on the equatorial line. So we want to calculate the electric potential. So the question comes, show mathematically that the electric potential at a point on the equatorial line of the dipole is 0. So this potential comes out to be 0. So the point P is at a distance r. This is the distance a. So by using Pythagoras theorem, the hypotenuse will be square root of base plus perpendicular. So it is r square plus a square. The same you will get on the another side, right? So at point P, the potential will be the sum of V1 and V2. V1 is the electric potential due to minus Q charge, and V2 is the electric potential due to plus Q charge. So V is equal to V1 plus V2. So the charge is minus Q and the distance is AP, right? So we write minus Q divided by AP. The charge is plus Q and the distance is BP. So we write Q by BP. Both have value under root of r square plus a square. We substitute in the both expressions. The minus sign is here and this entire term is exactly same but positive. So they get cancel out. Answer comes out to be 0. So we can conclude that the electric potential for every point lying on the equatorial line of the dipole comes out to be 0. The next is, if your point P don't lie on the axial line or on the equatorial line, it can be arbitrarily present around the dipole. It can be here, anywhere around the dipole. Then what will be the electric potential at that point? So the electrostatic potential at a point due to electric dipole, this point has no condition that whether it is present on the axial line or on the equatorial line, it can be present anywhere around the dipole. We choose a point P here, right, such that this point P has a distance r1 from the minus Q charge and this point has a distance of r2 from the plus Q charge. O is the center of the dipole. From the center of the dipole, this point has a distance r such that it makes an angle theta with the dipole axis. This r makes an angle theta with the dipole axis. If this is theta, then complete angle is 180 degree. So the remaining angle will be 180 degree minus theta. So the electrostatic potential due to minus Q charge, we are using the word electrostatic because the charges are not moving. The dipole is fixed at some point. So no motion is there. So the static word comes. The electrostatic potential due to minus Q charge at point P at this particular point is 1 by 4 pi epsilon naught the charge divided by the distance. The charge is minus Q and the distance is R1. So it is minus Q by R1. The electrostatic potential due to plus Q charge will be plus Q charge divided by the distance, that is R2. The total potential is sum of both V1 plus V2. Q by 4 pi epsilon naught can be taken common. Inside we are left with 1 by R2 minus R1. So 1 by R2 minus 1 by R1. Then we apply geometry. By geometry, you can write R1 square is equal to r square plus a square plus 2ar cos theta. So this is r1 r and this is a. This can be written as r square plus a square plus 2ar cos theta. Similarly for r2 square, we can write r square plus a square plus 2ar cos of 180 degree minus theta. When you solve this, it comes out to be minus cos theta. So negative sign will come here. First of all, we pick up this equation which says that r1 square is r square plus a square plus 2ar cos theta. We take r square common from the bracket. So here we will get 1 as r square is taken common. Here we need to divide with r square so that when you enter this r square in, you can again get your a square. And in this expression, if you want your r square to be common, one r is there and another r you need to put in the division. So this is the expression, right? If you choose your dipole to be very small, it means that a is very less as compared to r. So the square of a less number will be again very small. If I take 0.1 square, then it will be 0.1 into 0.1. I will be writing 0.01. This is again a further small number. So the square will be very small, so the square term can be neglected. Only r1 square is equal to r square 1 plus 2a by r cos of theta. We take square root, so r1 square root will give r1, r square root we written as r. Here you will get 1 by 2. Then we take the reciprocal of the terms. Similarly, we can achieve the things for 1 by r2. Then we substitute v is equal to q by 4 pi epsilon naught 1 by r2. r2 will be taken from here minus 1 by r1. r1 value is taken from here. We substitute the values. Then we apply binomial at this term and at this term. We know that the binomial theorem states that 1 plus x raised to power n can be written as 1 plus nx. We are going to deal with this term only. These higher terms can be neglected. In this expression, this is your x value and this is your n. N is minus 1 by 2 and your x is minus 2a by r cos theta. So it will be 1 plus nx. So it will be 1 by 1 plus 2a cos theta into 1 by 2. Negative sign will go, half will go. So you will get 1 plus a cos theta by r only. Similarly, for the second term, you will get this. On simplification, 1 and 1 will cancel out. You will get 2a cos theta by r. Denominator r and r get multiplied, gives you r square. Then q into 2a is called the dipole moment, which is represented as p. So it is p cos theta. This q into 2a is written as p. So it is p cos theta. Then we define r cap is the unit vector along OP such that the magnitude is 1. So we can write p cos theta as p vector dot r cap, because when you simplify it you will get p magnitude r magnitude into cos of theta. Dot product has this expression. So r magnitude, as it is a unit vector, it is equal to 1. So it will be p cos theta only. We substitute this expression here. On substituting, this is the equation or this is the expression for the electric potential due to dipole, right? If the point lies on the dipole axis, during that situation your theta is 0, means your point is lying on the dipole axis. So the theta which was made between the dipole axis and line joining the center of the dipole with the observation point, now that will be 0 degree or pi. So cos 0 is 1. So the potential will be V is equal to plus minus 4 pi epsilon by r square. The same expression we get for the first article which we did in this video. The next is if the point lies on the equatorial plane. Equatorial plane means the point lies on this line. During that situation the theta is going to be 90 degree and cos 90 degree is 0. So the electric potential due to the point lying on the equatorial plane comes out to be 0. So we have verified the things. Thank you for watching. Kindly like, share and subscribe my channel.